Hello guys and welcome back. So now we're going to continue looking at some more advanced features of the volume and learn about something called sign distance field. But before I do that, I want to recap what we looked at and what we learned. And so far we've covered volumes, and we learned that there is Houdini volumes and VDBs. We didn't use the Houdini volumes, and we're not going to do that at this point. We're going to focus all our effort in VDB, and we learned that we can do procedural volume manipulation in SOPs to create cloud. That's a very important part, using volume VOPs. We learned how to convert geo from geo to volume and create extra fields for smoke solver. Then we prepped the data in solver in SOPs. We passed it to the smoke solver, and then we imported back density plus temperature field, and that's what we're displaying. So this is what we've covered so far. And then we're going to take a look at a different type of volume that is called SDF. But first, let's revisit this. Cool. So we have the velocity. Because it's strong at the beginning, it's pushing the smoke quickly, and then there's enough temperature getting emitted over those 10 frames, so it builds enough velocity and pushes it. It's very, very cool for a quick example that we set up live, and I think there's a lot of cool details happening here. Okay, let's take a closer look at this volume, see if there is any more details. Actually, we're not looking at the volume at its full res. I thought that I'm doing the sim at full resolution, so let's do that together. Let's turn this on, and that should make the volume look a lot better. Let's hit play, and we should, yeah, we're getting more quality for sure. And the idea of the temperature or the explosion behavior is not necessarily tied to the pyrosolver. What the pyrosolver offers is it's a smoke sim, it's a smoke solver plus a combustion model. This combustion model can read in fields like the temperature field, the fuel and heat, which are required for the combustion model, and it generates an expansion and a new temperature field. We don't have to do all of that to just get some fiery look. We can just create our own temperature field and let the solver do its thing with the buoyancy and everything. Cool. And by the way, this is not simming at the moment. It's just the viewport that is taking this much time to display the volume at this resolution. There's definitely a lot of cool details here with the swirliness and the first part as well. Cool. So let's take one frame and zoom in to check out the details and everything. Cool. And this only took a couple of minutes, so on a very old machine. Let's take a look at the volume resolution. So yeah, we're still in the mid-range. We didn't get to the high resolution. I would call something high when one of these axes get to 450. But so far, I think there's a lot of details for this quality as well. Okay, so let's continue and take a look at this sign distance field thing. So I'm going to copy, or I'm going to create a VDB from Polygon. You can see once you create it, there's a distance VDB option. So let's plug that here, and let's leave the resolution at the default, and let's middle click, and it says surface. Under the name it says surface. We can change that name, doesn't matter at this point. Okay, and actually let's change it to density. And if we middle click, it says density, nothing special about it. It's a VDB data, but when we look at it, it doesn't look like a volume. It looks more like a surface. And let's lower the resolution even higher. Lower the voxel size so the resolution is higher. And look at that. From far away, it's a surface. It doesn't look like a volume at all. So why is that? Well, the reason for that is because this science distance field has more information about the geometry. So let me draw something. Let's say we have some shapes like that, and this is the geo, and we convert this into a volume. It's going to create the domain, and then fill the space where there is polygons or volume with density. So it will look something like that. Not exactly, but it will look something like that. Now, in the case of an SDF or a size distance field, how did it know how to display this as a geometry? Well, what happened is when the conversion from a geo, let's say this is the geo, to a volume happened, Houdini or VDB stored more information about this and created voxels that, apart from having a density value, they also know how far each voxel is from the surface. And this information is called the gradient. And this gradient tells each voxel how far it is from the isosurface. This part here that separates the 0 from 1 is called the isosurface. The SDF captures that nicely because it stores more data. And Houdini is currently using that gradient field to display, to fake the shading of a geometry. And this can only be done using a science distance field. Now, what are the advantages of this? Well, one main thing is we can look at it and see a geo. And we can also know how far we are inside the surface. Okay, so I can, for example, take this geometry and shrink it, and it will start going inside the surface properly because it knows how far we are. It knows the limit here, and each voxel inside this knows how far we are from the surface, so we can go dive inside this. It also has a fill in interior, which does a similar thing, and it will generate a lot more data. It's going to be heavier, of course, but by default it tries only to place voxels where it thinks there is data. This is one of the other differences between the Houdini volume and VDB. Houdini volumes will fill everything with data, whether there is data or not. VDB is very smart. It only places data where it needs it. Okay, so let's set this to 4. And again, this is not a surface. This is a volume. But this type of volume is not something that you can pass to the sim. You cannot send this to the smoke solver because it doesn't know how to deal with it. It needs an actual fog VDB. Well, how do we give it that if we have this? Well, we can use a node called VDB convert. And here you can convert a volume into a VDB into a volume. And right now it's converting from VDB into the Houdini native volume. Okay, so you can see it here. It did that. This volumes means there is a Houdini native volume, not a VDB. When you middle click here, it says VDB. We can also inside change it to VDB and tell it to change the class from an SDF to a fog, and that will give us the volume of convert the SDF into a volume, and this is something we can use with a sim. The other cool thing is we can take this VDB and also convert it back into mesh. If you middle click now, it's back into mesh. This is the SDF and this is the mesh. Now, why did it shrink? Well, that's because the isosurface is not very well determined. Okay, it can be here, it can be here, and we have a control for the ISO surface to shift that. So I can push it in, and now I'm shrinking the surface. This is not pushing along the normal. This is diving inside the data, and I can push it back up, and at some point it will stop because there is no more data at that level. See here, it's going to start stepping towards the end and then stops. That's because there is no more data stored in there. Well, how can this be useful for us? Well, I will tell you how. Let's say we want to create some cool dissolving effect, or we want, for example, something to start eating this geometry, and when it gets eaten, it converts itself into a volume, and we start emitting from that volume. Okay, to do that, we need to have a cool mesh so that we can see the part nicely, or the geometry nicely changing into a volume, but we don't want to see a hollow interior. We want to see something with details in there. Well, one of the main things that this VDB thing does, the SDF thing does, we can do very complex Boolean operations and between them, and it will generate a perfect mesh for us. So let's say we create a sphere. Let's say we create a sphere, and let me template this statue. We cannot template this because there is no wireframe to display perfectly. And I'm gonna move the sphere over here. Okay, I'm gonna add a transform, and I want to scale the sphere based on its centroid. So to do that, we can use an expression called $CEX, $CEY, and $CEZ. And now we can scale this, and it will reach the entire object. We need to fill it, basically. That's the idea. Cool. And let's change this to a primitive polygon. Let's increase the resolution. And I don't need all that data, so I want to remove all this. So I'm going to create a clip node because it's going to add to the overall result of overall data. So I'm going to add a clip node, and this simply clips the data, and I only need to leave the data here, so below. And then I want to cap this. I want it to be filled, so I'm going to use a poly fill, and I think it's best if I do this when the object is small, and then we can scale it from there. Let's move this. Okay, polyfill, everything's cool, and then we can transform it, and we can also use a let's scale it down, something like that. And now we can use a VDB from polygon to convert this sphere into an SDF. So VDB from polygon, and it's an SDF. I'm going to take on fill interior as well, and I want to keep both resolutions in sync of the sphere and the object. Shift and click and drag to move the whole chain. So let's copy, paste relative reference, and it's taking some time, and I'm gonna lower this to 0.1 so it's faster to work with. And I'm gonna turn off fill interior here and fill interior here as well, so it's faster to work with in both cases. I'm going to call this density to keep the same name. Okay, and what we can do now is we can use something called VDB combine. This is our SDF from the statue. I'm going to plug it in first. I'm going to plug the second one, and under the method I'm going to say SDF difference, and now it's removing that sphere. See where there is collision? It's removing that. So I can scale it up, and it's going to eat away the statue. Okay, well, let's say we take this. Actually, let me increase the resolution to show you the result nicely. Okay, we can take this result and convert it back into a geometry. VDB convert. So now we have a geo, and if we zoom in, it's perfect. This is filled. We can use the adaptivity control so that it better places the polygon tool only when it's needed. And then we can do another copy of the VDB combine and change this to SDF intersection, and this will give me the rest. This is the leftover and this is the intersection, and I can use this and say VDB convert SDF to fog, and look at that. Now we have our geo, and this is going to be the emission. Now let me go to frame 1 and let's template the statue. I want to do some animation with the hand. So that, I'm going to set a keyframe, go to frame 60 and increase it to encompass everything. Okay. So this is gonna generate a full sphere, and we should get back the full geo. So now we're gonna emit from everything here. Okay, let me untemplate the other guys. So now at this point it's gonna emit from everything, and if we start going backward, we're gonna see this emission getting eaten away. And at the same time, let me Control-Shift-Click this, which is the leftover geometry, and if we play through, you see that it's transforming that piece into a volume, and then what's left is a geo. But obviously everyone is going to say, oh, we want the scene to get fixed. So let's simply add some noise to the VDB from polygon. Now this is called density. Let's grab one of these guys that deforms the cloud and see how it works here. If not, then we can deform. If we can do it at the SDF level, that's good. If not, then we can change the input geometry, which I think will be easier. Okay, so we don't need to add 2 noises, just one. And let's set this to 1. And let's set this to 2 maybe. Set this to 0.2, 0.2, 0.2. Okay, and the reason we're doing deformation to the SDF, the reason it's giving us those black holes is because there is no more data to work with, and this is where these guys, we need to add some padding to both sides. If this fixes it, I will use it. Otherwise, I'm going to use just add noise to the geometry itself, because it's going to get slow at this point. Yeah, it's already slow. Let's see. Come on. Cool, much better. So let's use this. And let's see the result. Yeah, it's not working. So I'm not going to deform the SDF because this is much more complex processing, and I'm going to simply set these to 3. I'm going to go back to the sphere and do what I should have done. Add some noise to it. something like that. We can increase the resolution. It's not going to affect the performance of the VDB generation too much. This should be quick. Yep, and let's use that instead. Cool, and now it's working, and the edge is broken. Let's control click here. You can see the edge is getting better. I mean, we can increase this more. 3 maybe. Okay, let's lower the size to 1.5 so we get more frequency. Something like that. And I'm going to, let's check this resolution. Yeah, I think this is good. So I'm going to write both of these guys to disk because this processing is heavy. I don't want to keep wasting time every time. So I'm going to say source from SDF. From SDF. And then this is going to be the geo. Geo combine result. Select them, right click. I'm going to do 60 frames or 61. And let's hit save to disk. And it's going. I'm going to pause, and actually I'm going to stop here and we'll continue in the next video. Thank you guys for watching, and see you in a bit.